In this video, we're going to look at what are known as conic sections. We're going to look at parabolas specifically, but we're going to see parabolas as one example of what are known as conic sections. So conic sections are all of the shapes that arise from taking two cones and inverting them like you see here in the white. So this white cone, these are open on the inside, so they're just 1 point thick. It's actually, if you imagine taking two intersecting lines in the plane and then spinning them around, then it's going to create this three-dimensional object that's known as cones. So it has the top half and the bottom half of those cones. So if we then take a plane and intersect it with that cone, the intersection is known as a conic section. So if we take a plane, for example, this blue one, that is parallel to the floor, and we look at where that intersects these cones, we'll see that that's going to lead to a circle. If you take a plane, and this is kind of hard to show, and you tilt it a little bit off so it's not parallel to the floor, and then you intersect it with that cone, you're going to get something that's kind of a distorted circle. We're going to call that an ellipse. And if we take a plane that is parallel to one of these lines that form the original cone, then if we run that into the cone and intersect it, we're going to get a parabola. And so a parabola is one of our conic sections. And then finally, if we take a plane that is parallel to the side wall and run it over to where it intersects the cone, it's going to intersect both parts, the top part and the bottom part. And so we'll get something that sort of looks like two parabolas, but it's not quite a parabola. That's going to be known as a hyperbola. Additionally, there's what's known, just kind of more of a trivia question than anything that's a big deal. If you took a plane that was exactly parallel to the floor and intersected it just right, it would just intersect at a single point. That's known as a degenerate conic section. If you took a plane that was exactly parallel to this one of the original generating lines and took a plane that just intersected there, you could get a single line as an intersection that also is going to be a degenerate conic section. Or if you took a plane that was exactly where this iPad is and run it across through here, you would get these two intersecting lines. So that's not a big deal. That's more of a trivia kind of question, but point, a line, and two intersecting lines are also known as degenerate conics. Okay, so let's look more in depth about our parabolas. So we have seen in the past the parabolas in the form y equals ax squared plus bx plus c. We call that standard form. We know about vertex form, y equals a times x minus h squared plus k, where our vertex is going to be that hk. And we're going to also extend this and look at now parabolas that open right and left that will look like x equals ay squared plus by plus c. Or if we complete the square in vertex form, a sideways parabola will look like x equals a times y minus k squared plus h. And in this case also, the vertex is going to be h and k. So our definition for a parabola is going to be the set of points in the plane that are equidistant from a fixed point that we're going to call the focus and a fixed line, which we're going to call the directrix. So for example, if we have a parabola that opens up or down like this green one, the focus will lie on the interior and the directrix is going to be a line then that's going to be horizontal. So this is y equals, I'll just say d. Now, because every point on this parabola is equidistant from the focus and the direction, and the directrix rather, this distance is the same as this distance. Okay, so the distance from a point on the parabola and the focus is the same as the distance from the point on the parabola to the directrix. And that's true for all of the points on the parabola. And we measure distance from a point to a line as that perpendicular distance. So we're saying these distances are the same no matter what point we pick on the parabola. Okay, so focus on the interior and directrix is going to then be on the exterior. If we have a sideways parabola, oh, and I should also say this is also our vertex, as we have seen before. It's that lowest point on a parabola that opens up. If our parabola opens to the right or left, then this is going to be our vertex. Our focus will be on the interior, and our directrix then would be a vertical line. And again, this distance is the same. The distance from a point on the curve to the focus, and that distance from the point on the curve to the directrix. And likewise, for any point that we pick, the distance from a point on the curve to the focus is the same as the point on the curve to the directrix. Okay, so let's see how we can use this. Some examples of problems that we're going to do. Can we find an equation of a parabola with vertex 1, 1 and focus 2, 1? Now you don't have to draw a picture, but I think it kind of helps a little bit to see what's going on here. So our vertex is going to be at 1, 1, and our focus is going to be at 2, 1. So it's going to look something like that. Since the focus is always on the interior, that means our parabola is going to have to open to the right. Oh, and I should tell you, let me back up to that other one. I'm leaving off some important information about the relationship here between these distances. So the distance from the focus to the vertex, which is also the same as the distance from a point on the curve, in this case the vertex, to the directrix, that we are going to call P. So P is the distance from the vertex to the focus. And that's also going to be the same as the distance from the vertex to the directrix. Now, it turns out that we have learned before that this number A, this value of A right here, no matter which form of the parabola we're talking about, it is going to determine the shape and the direction of the parabola. For a parabola that opens up or down, like the y equals, then if the A is positive, it's going to open up, and if the A is negative, it's going to open down. A larger value of A is going to be a skinnier parabola, and a smaller value of A is going to be a flatter or fatter parabola. Similarly, for an x equals y squared parabola, a positive value for A means the parabola is going to open to the right, and a negative value for A means the parabola will open to the left. And as before, a larger value of A will make a skinnier parabola, and a smaller value of A will make a wider or fatter or flatter parabola. So the A completely determines the shape of the parabola. The rest of the stuff just moves it in the plane, so its vertex may be a different place than the origin. But the key relationship is that A, that coefficient of x squared that determines the shape, is 1 over 4p, where p is that distance from the focus to the vertex, from the vertex to the focus. Okay, so now let's come back to the problem we were going to try to do here. We're trying to find an equation of a parabola. It's got vertex 1, 1 and focus 2, 1. So we can see it's going to open sideways. So we know right off the bat it's going to be a parabola of the form x equals a times y minus k squared plus h, because it's a sideways parabola. We know the h and the k are going to be the vertex. So in this case, they're both 1. So far now, we know that x is going to be a, which we're going to figure out in a moment, and it's going to be a y minus 1 squared plus 1. Now, the distance between the vertex and the focus, that distance is 1. That is our value of p. The a is 1 over 4p, so that is going to make a 1/4. Now, because it's opening to the right, then we know this is going to be a positive a, and so our equation of our parabola is going to be x equals 1/4 times y minus 1 squared plus 1. See how that works? Let's try another one. So our vertex is at negative 2, 1. That's going to be right about there. There's our vertex. And the directrix is going to be x equals 1. X equals 1 is going to be a vertical line. So there is our directrix. So that means our parabola is going to open to the left because it's going to go away from the vertex. This distance right here from the vertex to the directrix looks like it's going to be 1, 2, 3. That is our value of p. That makes a 1 over 4p is going to be 1/12. Because this parabola is opening to the left, we know it's going to be a negative 1/12. And the vertex is going to give us our h and k. And because it's opening right and left, it's going to be an x equals y squared. So it's going to be an x equals, there's the a, negative 1/12, times y minus the y coordinate squared plus the x coordinate. So that is the equation of our parabola with vertex negative 2, 1 and directrix x equals 1. Now we're going to do one that has a vertex at negative 1, 2. So there's our vertex. And the focus is negative 1, 0. That's going to be right there. So we can see that it's going to open down because the focus is going to be on the interior. So it's going to be a y equals x squared parabola. We can see the distance from the vertex to the focus is 2. That means a is going to be 1 over 4 times 2 is 1/8. Because this parabola is opening down, that's going to be a negative 1/8. Our vertex gives us the h and the k. Because it's a parabola that opens down, we're going to get y equals a times x minus h squared plus k. So that's going to be y equals negative 1/8 times x minus the negative 1 is x plus 1 squared, and then plus k is going to be a plus 2. Okay? Okay, now different kind of problem. This time we're going to find the focus and directrix and graph y equals negative 1/2 x squared minus x plus 1/2. So, and when we do this, we're going to find 3 points. We're going to find the vertex, and then we'll probably just get a couple easy points, maybe the y-intercept and the symmetric point, and then we'll label our focus and directrix. So the hard part is always finding the vertex. So we have a couple of standard ways. One is, if you remember, that x will be negative b over 2a is going to give us the x-coordinate of the vertex. So negative b is going to be a positive 1, 2 times negative a half is negative 1, so that makes the x-coordinate of the vertex negative 1. We'll plug that into our function, so we'll get y equals negative 1/2 times negative 1 squared minus negative 1 plus 1/2. So negative 1 squared is 1, times negative a half is negative a half, plus 1 plus 1/2 looks like 1. So our vertex is going to be negative 1, 1. So there's negative 1, 1 right there. We're going to make it easy on ourselves and just plug in 0 for x. That looks like 1/2. So the point 0, 1/2 is an easy one to find, and that's the y-intercept. Using the symmetry, we know this is a parabola that's going to open down since it's a y equals negative x squared. So on the other side of the vertex from the y-intercept is going to be the point 2, 1/2, and we're going to get our nice parabola that opens down. Now we know that the a is 1 over 4p, so negative 1/2 is 1 over 4p. I'm going to take the reciprocal of both sides, so that's going to be negative 2 is going to be 4p, so p is going to be negative 2. I don't really worry much about the negative sign. I know that the focus is going to be on the interior, so I'm going to have to go down from the vertex 2 to get to the focus. So that's going to make the focus have coordinates negative 1, negative 1. And I'm going to go 2 in the other direction, that's up, to get the directrix. And that's going to put us at 1, 2, 3. So that's going to be y equals 3. So I have also labeled the focus and directrix. Let me just remind you of the other way we have of finding the vertex, and that's by completing the square. It's been a little while, so these are still skills we want to keep sharp. We're going to need these. You can use it for the parabola, but it's not required. But when we start talking circles, ellipses, and hyperbolas, we're going to have to be able to complete the square. So this is a good chance to kind of review that. I'm going to factor the leading coefficient just out of the first two terms. So factoring out a negative a half will make that be x squared. Remember, when you factor out a negative a half, you divide by negative a half, which is multiplying by its reciprocal, negative 2, which is going to make that be a plus 2x. I'm going to leave a space and move the 1/2 to the outside. I'm going to then take half the middle term, which is 1, square it, which is 1, and add that in. That gets multiplied by the negative 1/2, so adding in 1 is really adding in a negative 1/2, so I will make that be 0 by adding a half. So the net change is 0. Then in vertex form, we're going to get negative 1/2. This will now be x plus 1 squared plus 1. So that's a lot of work to do to see that the vertex is going to be a negative 1, positive 1, which we also got using x equals negative b over 2a. Okay? All right, let's try one with a parabola that's going to open right or left. So now we have an x equals y squared, only it's not written in x equals y squared form yet, so we need to do that to start with. So I'm just going to add that 4x to the other side, so that'll be 4x is y squared minus 4y. Then we'll have to divide by 4, so that's going to be a 1/4 y squared minus y. So here is now our parabola in standard form. We can find the vertex. Now here, because it's an x equals y squared, what we're going to do is get y equals, oops, I lost my pen there. we're going to have y equals negative b over 2a instead of x equals negative b over 2a. So our b is going to be the coefficient of the y term. So that's going to be a negative of negative 1 is 1. 2 times a is going to be 2 times 1/4, which is 2/4, which is 1/2. To take 1 divided by a half is the same thing as 1 times its reciprocal. So that's going to make the y-coordinate of our vertex be 2. We can plug it in and find out what the x is. So we're going to get x equals 1/4 times 2 squared minus 2. So 2 squared is 4, 1/4 times 4 is 1. 1 minus 2 is going to be negative 1. So that's going to make our vertex be negative 1, 2. So I'm going to draw our xy axis over here. And we're going to go to negative 1, 2. We know since x is equal to a positive y squared, this is going to open to the right. So I can safely put the vertex over here on the left and not get in the way. Now if we plug in a 0 for y, we're going to get 0 for x. That means that 0, 0 is going to be a point on this parabola. We know it's going to open to the right because it's a positive x squared, or x equals a positive y squared. So using the symmetry, we'll go up 2, and that's going to make 0, 4 another point on this kind of wide flattened parabola. Now we know that a is 1 over 4p, and the a is our coefficient of the squared term once we have x by itself. So if we take the reciprocal of both sides, we'll get 4p is equal to 4, so p is equal to 1. So that means from the vertex going to the interior, we're going to go over 1. That's going to make that focus be at 0, 2, and going 1 in the other direction is going to give us our directrix, which is going to be x equals negative 2. Okay, very good.